Okay, so for Advanced Algebra Trig section 5.3, we're talking about rational functions, okay? And we had three warm-up problems that we did together in class. We talked about x cubed minus 8. That's the difference of two cubes. Remember how to factor that? It becomes x minus 2 times x squared plus 2x plus 4. Remember that this is like x being cubed minus 2 being cubed. And then the formula gives us the answer right there. So don't forget that one. We did a simplifying problem where we had x minus 2 over 2 minus x, multiplying top and bottom by the bottom by a negative 1. This is the same thing as the idea of the switcheroo I introduced back in chapter 1, and that gives you a value of negative 1 when you do it. So negative 1 times the bottom gives me negative 2 plus x, and then multiplying by negative 1 gives us the negative 1. And then number 3, sketching a rational function. F of x equals 1 over x minus 3. This is the Hurley graph. This is the original 1 over x function, but then it's been moved 3 units to the right. So you can see over here in my graph, that's exactly what we have. We have the Hurley graph that has been moved 3 units to the right, and as you can see, right at 3, there is a vertical line. That's going to be our vertical asymptote. We'll talk about that later. And so our domain for this function, we wrote down, we said the domain was all real numbers x such that x was not equal to a positive 3. And again, that's consistent with dividing by 0. So that was the warm-up, and that led us right into what the definition of a rational function is. So the book gives us the definition of r of x equals p of x over q of x. And p of x is just a polynomial, and so is q of x. So basically, we're just taking two polynomials and dividing them and getting a rational function. But of course, q of x cannot be 0 because we're never allowed to divide by 0. So if I had to give you like an example of this, right, I could say like 3 over x plus 5, right? This is a rational function, right? And the 3 represents the p of x, and the q of x represents the x minus 5 right down there. So that's a rational function, and that's what we're going to be using it. And today the only idea we had to come up with was how do you find the domain for a rational function. So I gave this example. R of x equals 2x squared minus 4 over x plus 7. Again, the 2x squared minus 4 represents p of x. The x plus 7 represents the q of x. And so what we do is we're going to set q of x equal to 0, factor, and then solve. So set the x plus 7 equal to 0, subtract 7, and you can see that the domain for this function is all real numbers x such that x does not equal negative 7. So this counts as our domain for r of x. And then we had another example here, 3 over x squared minus 9. Again, it's a rational function because it's just a polynomial over another polynomial. 3 represents the p of x, x squared minus 9 represents the q of x. So again, to get the domain, we're going to set q of x equal to 0 and solve, so we factor the difference of two squares, and the domain is all real numbers x such that x is not equal to plus or minus 3. And it's okay to write your answer just like that. Alright, and then the third box was just another example. Find the domain, 5x over x to the third minus 8. And notice the x to the third minus 8 was the exact one that we did when we factored in the warm-up. So I wanted to make sure that everyone had the x minus 2 and then the x squared plus 2x plus 4. So if you look over here, what we did was we set q of x equal to 0, x to the third minus 8 equal to 0, solve. On the real solution here, we have x is equal to 2, and then we have a quadratic left over, so we need to check this quadratic to make sure that it doesn't have any real solutions. So we figured out a, b, and c. A is 1, b is 2, c is 4. Checked the discriminant, and we came up with a negative 12. That implies that there's no real solution. So therefore, the domain for my rational function is all real numbers x such that x is not equal to 2 from this solution over here. And that is what we did for the first section of 5.3.